So we'll wrap up this section. We've got 2 more to go through on this section, but I'm just going to do the first part of each one. Well, I don't know. We'll see. I don't know. All right, so the first one, I've got the limit as x approaches 3 of x squared plus 7. And so what I have is find your delta such that your epsilon is less than 1/10. Or sorry, 1/100th. And you're going to turn around and do the 5,000ths one. But I'm going to do the 1/10 one. So what do we have? First of all, I need to find the limit. So that is step 1. So step 1, do direct substitution. So take your 3. 3 squared is 9. And 9 plus 7 is 16. So I end up with my limit is 16. So my epsilon, I was told, is 0.01. Okay? And so when I do this, what I have is, hang on, let me pause for 1 second. Sorry. My family was bellowing in the background. All right, so what I have is, my epsilon is 0.01. So what do I do with my epsilon? With my epsilon, I'm going to add and subtract it to 16. So when I add it, I get 1601. When I subtract it, I get 1599. Okay, so those are the y values. That's the interval on my y values that I'm okay with generating. So now what do? Take your function, which is x squared plus 7. So x squared plus 7 can either equal 1599 or x squared plus 7 can equal 1601. And I'm going to solve each one of those. So when I subtract 7, I get x squared equals 15 minus 7 is 8. So I get 899. And I'm going to take a square root. Now normally during the process of solving a problem, if you've got to take a square root, you would take a positive root and a negative root. But since I'm dealing with a positive 3, I only need to take a positive root. So take a square root of both sides. So I get an x of 8.99, and I get 2.99833. So 2.99833,287. 287. Okay, so that's the lowest x value at this point that I'm okay with generating. So this one, subtract 7 from each side, so I get 901. And now take a square root. Again, take a positive root. So I have, this is going to give me 3.00, so 3.001666204. 204. So that's your interval for x values, but I need to know how close to my target x to be. So I'm going to take 3 and subtract this number, and I'm going to take 3 and I'm going to subtract this number, and I'm going to find out and choose between my deltas. So 3 minus this one is going to give me 0.01662, which I already knew that piece of trash. All right, so this delta, sorry, I just did that backwards. Just kidding. All right, so this delta is going to be 0.016666204. This delta is going to be, so do 3 minus, and I get 0.0166713. So 0.001666713. Okay, so I'm supposed to, by instructions, round to 5 decimal places. So this is 1, 2, 3, 4, 5. So that's going to be a 167. This is a 1, 2, 3, 4, 5. So that's a 167. And so all we have for an answer for our delta is 0.00167. And that's going to be your delta. So as long as you are this far away from 3, you will be within this interval. And that's all you need to know. So that's how far you are. All right, so you're going to do the second half of this one. And then for the last one, oh, there's 2 more. All right, so for the last one, we have a jeweler resizes a ring. So this is a practical application, and most people hate application problems, but this one you'll be able to see actually why this is important. So I have a jeweler resizes a ring so that its inner circumference is 10 centimeters. So what's the radius of the ring? So first of all, I need to know what my formula is. So I know that the circumference of a circle is 2 pi r. Okay, so the limit of 2 pi r. Okay, so that's your function. That's the formula for circumference. And I need that to be 10 centimeters. So I need to know what the radius of my ring is. Okay, so right dead off, I need to know what the radius of my ring is. So I have 2 pi r is going to equal 10 centimeters. So I'm kind of sort of working backwards here because I haven't set up the limit yet because I don't know how close I need to be. All right, so what is your variable here? 2 is a number, pi is a number, r is a variable. So I'm going to divide both sides by 2 pi. Be careful when you do that to put your 2 pi in parentheses. Otherwise, that's an E. Otherwise, it's going to do 10 divided by 2 and multiply your answer by pi. That's not what you want. So I get 1.591549, blah, blah, blah. So 159. And then how close am I supposed to be? Hang on. 4 decimal places. All right, so 15915. So if I have a perfectly sized ring, okay, then as my radius approaches 1.5915, then my limit will be 10. It'll be 10 centimeters of a circumference. So now this is your analytical setup. We're all done with that now. All right, so what's the next question? That was the radius. If the ring's inner circumference can vary between 9.5 and 10.5, so my answer can vary between 9.5, which is 5/10 less, and 10.5, which is 5/10 more. That means my epsilon is 0.5. Okay, so we're kind of sort of applying what this stuff means. So if that's what my inner circumference can vary, how far can the radius vary? So I need to be able to generate, well, what x values or what r values can I use for my radius? So if my epsilon is 0.5, I'm going to subtract it and get 9.5. I'm going to add it and get 10.5, and then I'm going to use my equation and I'm going to solve for r. So 2 pi r equals, 2 pi r equals, okay? And then I'm going to divide both sides because, again, I want to know what the radius is. If my circumference is 9.5, so I'm going to divide both sides by 2 pi. So 9 divided by parentheses 2 pi is going to give me 43/24. So 43/24 is the smaller end of the radius, or 10.5 divided by 2 pi is going to give me 67/11. So 1.6711. So this is the smallest that the radius can be, and that'll generate a 9.5. This is the largest that the radius can be, and that'll generate a circumference of 10.5. Okay, so what can your radius be between? Well, my radius can be 143/24. So 143/24 all the way up to 167/11, whereas my target radius was 159/15. Okay? So now set this thing up. Use an epsilon delta definition to describe this situation if your epsilon is 0.5. We've already done it. So the limit as your radius approaches your exact target of 15915 of what's your formula? Well, my formula is 2 pi r, and that should generate a 10. What is your delta? Okay, so if you are only allowed to vary between 9.5 centimeters and 10.5 centimeters, what's your delta? So I need to find out how far away this radius is from my target. So 1.4324 minus 1.5915 gives me 1591. So that's how far this radius is from my target. And then what is this one? So 6711 minus 15 gives me 0796. So 0796. All right, so how far, I have two different deltas. And so how far away am I going to be? Holy cow. I'm sorry, I'm re-guessing myself. I screwed it up here. This says 9 divided by 2 pi. It's supposed to be 9.5. 9.5 divided by 2 pi gives me 151197. So that ends up being 15120. That's a whole lot more sense. 15120, which when I subtract that one off, sorry, all right, minus 15915 gives me 0795. So this one is 0795. Okay, so you have a difference. This delta does not match this delta. So if they don't match, who do you always grab? Always grab the smaller one. Okay, if you grab the larger one, then your circumference is going to be too big. It'll either be up at 10.6 or down at 9.4, somewhere in there. So always grab the smaller one. All right, so your answer, now that I fixed that stupid mess, is, hang on, 5120. So 15120. So what was your delta? Your delta is 0795. Okay? So I'm sorry. I'm doing these like I've done 14 of these today. So my brain is swooshing. All right, so we're going to try the same thing. I have a sporting goods manufacturer designs a golf ball that has a volume of 254 cubic inches. Okay, so I need to know what's the radius of the golf ball. Well, if it's volume, how do you find volume of a sphere? The volume of a sphere is 4/3 pi r cubed. Okay, so this is going to be the same setup, and I'm going to rip through this one, sorry. All right, so I need to know if that's the volume, what's my radius? Okay, so I'm going to set this equal to 251, and now I'm going to solve for r, which means first thing I'm going to do is multiply by 3 and then divide by 4. Okay, so 2.51 times 3 divided by 4, and then divide that answer by pi. So right now I've got 188.25. So divide that by pi, and that gives me 599.21 something or another. So 599.21, 83,607, and that's what r cubed is. So I need to take a cubed root. So what I've been doing on the side over here is I've been raising, let me see if I can show you. When I've been taking roots, I've been raising it to the 0.5 power, because remember a root is just like 1 over the value of the root. So here's one. I did 9.01, and instead of taking a square root and doing all that mess, I don't know if you can see this. I'm getting really close. There you go. I did 9.01 raised to the 0.5 power because it's 1/2. So on this one, I'm going to take this answer. And again, you can do second entry if you just need to redo the answer. Or, all right, so I need to do the answer, and I'm going to raise that to the 1/3 power, because a third root I can use as an exponent and do 1/3. So that gives me 8431. So my radius needs to be 8431. Okay? 8431. All right, so if the ball's volume can vary between 248 and 254, okay, how can my radius vary? So the first thing I want to know is how close am I supposed to be? So my target is 251, and I can go down to 248, and I can go up to 254. So my epsilon is going to be 0.03, because I subtracted that, and I added it to this to get these two values. So I know epsilon is 0.03. All right, so how do I figure this out? I already know what my formula is. So it's 4/3 pi r cubed can equal a lower value of 248 or a higher value, an upper value of 254. What time is it? All right, I only have 45 seconds. So bottom line is you're going to rip through this and solve for r, okay, and then subtract. So what is your epsilon? I already found my epsilon is 0.03. My limit as r approaches 8431 of 4/3 pi r cubed needs to give me this exact answer. So you just have to go from here and find your delta. And then that one's done, and 1.2 is done.